Okay, so now would like to write a method that's called public void decrease key int I t key in the min heap class that replaces the value at the index I with the given smaller key and restores the heap property. So we must check that the index I is valid and that the key is indeed smaller than the value being replaced. And if either is false, then we don't do anything. And then we'd like just to test this method and see it's working. Of course, now the thing is, by decreasing the key, sometimes we need to change or percolate up just to put that value up. So what does this mean? I don't know if everybody understands what this is. What does this requires us to do? We would like to be able to change the value inside of the heap, to decrease it only. We're not allowed to increase it. So if I specified an index and then I'm increasing the value, I'm not going to do anything. If I'm specifying an index and that index is not valid, it doesn't exist, then I'm not going to do anything. But if you give me a value that is smaller than the value that was there before, I will change that to the new value, but I need to not to forget to build it again, sort it again. So basically I'm just going to call the bottom up because that's the simplest or the most efficient approach. So that's what we're going to do, which is, again, this is really, that's not that complicated, but once I know how to do that and what I need to do here, the rest is simple. I mean, now I just need to have this decrease key. So the first thing is that if the I is first of all greater than or equal to 0 and the I is less than, how do I know the size? Heap dot the size. So if this is smaller than that, I'm not going to be doing anything. It's going to be falling to the else, and I'm not going to do anything. Or maybe if I'd like to make it specific, I'm going to do if it's negative or if it's bigger or equal to the size, then I'm not going to do anything. Return. Return just stops this from, stops the method from happening, right? Or I just, well, I can do return, or I can just to show that I'm stopping. So I can, if I'm in this case situation, I'm just going to get out. Now that's the first situation, that if it's invalid, you stop. But if it's not invalid, I need to check another thing. So what is the other thing? Or maybe else if. Yeah. Anyways, else if what?
The number that he's entering.
So this key
is greater than the.
So how can I say key is greater than what?
I think he wants the key to be less than I.
We want it to be less than I?
Yeah.
I is the index. No. Less than the value that is inside inside the heap. So how can I get the value inside the heap at the position I?
By getting from search. You will have search.
By get?
I.
No, just get. Not search. I don't need to search. You give me a get, you give me an index.
Yeah.
So if it's greater than the value that was given here, then I'm going to return again, right? I don't know. I'm going to improve this. It's not good. But there's a mistake here. What is the mistake? What's the problem?
The type of different.
What is the problem? The type is different? That's the problem?
Bad operation.
I'm sorry?
Bad operation.
Bad operation. What does this mean? Bad operand. There's not bad operation. Bad operand types.
Operand.
For binary operator.
We need to do compare to.
Yeah, exactly. We cannot use this for these class data types that are not comparable, but we can use compare to compare between these two. So I need to use this compare to this thing, and then how do I know it's bigger if it's positive? If this key is bigger than this, that's what this question is all asking. And if you get confused with what should it be, positive, negative, just follow the sign. What you want to do, you would like this to be greater than this. That's what the compare to is going to give you. So you see the sign, the direction of this is going to be the same. So I want this to be greater than 0. That means if I put this, that means I want this to be greater than this. If I make it less than 0, that means I want this to be smaller than this. So that's why you always follow this. They put it with, when you design, when you develop, when you implement, sorry, this compare to, you implement it in a way so it will be, if the first one, this one, is greater than the other one, then you put a positive number. So that's why you can just always keep the direction so you don't get confused.
Because every time I get confused with it.
And this is how not to get confused. Just what you want. First one greater than the second one, so that's how the compare to should return. It's something positive.
Compared to with sign.
So now would like this actually to be more, better. I'm just going to do something like this. And so if this is happening, or if this is happening, I'm just going to stop. And it tells me unnecessary return statement, yes. But well, now the opposite of this, that means if I don't put anything, I just would like to. So if this is greater or equal, and this is less than the heap, this is the first part. So if this is true, and if this is true, if it's the key is bigger, no, we don't want it. We want the opposite. If you want the key to be smaller, so if all these are true, then I'm going to do this work that I would like to do. So else, I'm not going to do anything. I'm just going to get out. So instead of doing this return, there's another way to do that. And let's do it this way. So this is about the condition about the I is valid, and this is the condition about the key is valid that was given. Now if all of these are okay, then what I need to do, how can I do that? Heap dot so there's something that replaces or insert. There's a method. What is it? The method set. The set is what allows me to change an index of an element at a specific index. So it just replaces the element at the specified position in the list with the specified element that was given. So that's what I'd like to do. It's a set. So in the I, I'm just going to put the key. And then, no.
But this one for the array list first.
Yeah, that's my heap. My heap is in the array list. And then I'm not done, because I might be in a situation where now the child is smaller than the parent.
Now we have to do the first part, put everything in.
Just build the heap bottom up. This is going just to check each one that is still repeating from the bottom up and make sure that everything is okay. And this is going to allow me to decrease that. Is that okay? Not sure? Let's test it. I'd like to test it again the same way that I did here, except that I'm going just to do it like this. I'm just going to keep this array because it's convenient. Now I'm just going to call this heap dot What did I say? Decrease.
Decrease key. Yeah.
Decrease key. So which one I'd like to decrease? First of all, you know what? Before doing that, if I have this as my array, I would like to my heap here is a min heap, so I'm just going to do this new min heap and give it the array. Why am I doing this? Because I'd like to build this heap, and then I'd like to print the heap. Can I print it? There's this heap printer, but how is it going to, every time it just prints it like this. So let me just print my heap. So just without doing anything, I just insert these. I would like to see my heap, how is it going to be. Now by printing it, this is my heap. Okay? Now what I'd like to do, just to see, I would like to change, I would like to change something. If you'd like to change 8, you have to tell me what's the index of 8. Can you tell me what's the index of 8? 0, 1, 2, 3, 4. Not necessarily. Because now, when we insert it in the heap, we just change it to make sure that we find it at its position. This is 0, 1, 2, 3, 4. Well, it appears to be the same place, but actually just like it's not like a rule. It just happened to be like that.
But the 0 is not in the same place.
But the 0, as you can see, obviously is not in the same place. 0 is the position 0 now. But so you don't just always look at just the position here initially. Initially it was here, but let me just do something, you know what? So I just make sure that it's not. Now if I build this heap, I'm going to run it again. Well, it just looks like it's going to bother me. Let me put it in a place. But again, this is going to probably be the same. No? This is how it was.
Just
No.
8 before 6.
0, 1, 2, 3. Yeah, anyways. Yeah.
When you start with an index, you start from left to right.
Yes, because that's how we insert them, right? So this is 0, 1, 2, 3, 4, 5, etc. This is the array. 0, 1, 2, 3, 4, 5, etc. And then keep going from the left to the right. Now if I'd like to change, what I'm going to do, I'm just going to copy this and change it later and display it later. But now before, I'm just going to heap.decrease decrease the key. Now to decrease the key, okay, that's, I would like this to be, let's say, which key you would like to change. Let's say the first one.
Okay, go ahead.
Now the first one, just would like to make sure that this is, I'm not changing 2, I'm changing the 0, because now the 0 is the 1. So if I put something that is not, I mean, smaller, let's say I'm putting something like this, nothing is going to happen. So it's going to just show me, this is before, this is after, nothing happened. Why? Because I gave something that is bigger than what was there. But now let me put something smaller, and then it just changes that to here. Now let's do something on the bottom. Instead of the 0, I just would like to go for 0, 1, 2, 3. So this 3, I would like to put -1, because -1 should be now the top, right? So I just would like to show that we need to put it back up. And let's run. This is how it was before. Now by replacing this, -1 became on the top, and then we just percolated up to reach that. Yes. With what?
1.
You want to try it with 1?
Why 1? We have already 1.
Well, that's what you get.
So it should be like that. Not repeat.
No, it can allow repetition. Yeah. This is not like the AVL or the binary search tree. So that's the how we test our code. Is that okay for this to be?
I mean, when you ask us, we should put also to not be.
Well, no, because the heap